Hello, my name is Josh Howard, and I'm here with Hope Tech. Hope Tech is a community development nonprofit that has two main programs, Hope Tech and Hope Literacy. We are focused on creating accessible educational opportunities that fuel lifelong learning. And today we're going to begin our second course in our Solidity series. In the last video, I mentioned I didn't know what the SPDX license identifier is. So I looked it up, and it stands for Software Package Data Exchange. These licenses help developers with compliance. I put a link in the description to a list of licenses so you can look for one that best fits your development needs. If your code is not open source, you would use unlicensed. Today we're going to walk through the subcurrency example in the Solidity documentation. The documentation defines this as the simplest form of currency. So let's begin. So why don't we switch over to Remix here. Last time we did this example of storage where we wrote a simple smart contract and we utilized two functions, a set function and a get function. And then we created this contract with an unassigned integer called store data. And what this is a state variable that we can assign a unit to, and then we can get that function and see what is stored at stored data. And today we're going to look at, like I mentioned before, the idea of subcurrency. And we're going to go ahead and start with our license, just like we did before our license identifier. And so I'm actually just going to copy and paste that into here. So again, it's the SPDX license identifier GPL-3.0. You can look at the details of what this license is in the link that I provided in the description. And then we start with Pragma, Solidity, and then remember the little hat designates that this will work on this version of Solidity and any future versions. And remember, you can always bound the versions of Solidity that you're allowing your contract to run on. So next we're going to initiate the contract. Then we will call out an address, which is a type of state variable used to store an address or the public half of a key pair. Now, a key pair is actually pretty complicated. Essentially, a public and private key are used to identify Ethereum accounts. The private key is like a signature used to sign the transaction on the blockchain. The public key is derived from the private key in a complex method. I'll probably make a video on this at some point, but I did provide a link in the description so you can start to dive into key pairs. But for now, I think we can just accept that key pairs exist and not worry about it too much. So let's begin the contract, and we're going to type contract, and this is similar to what we did before, and we're going to just say coin. And you could put in whatever you want here. So maybe we do tech coin for fun, or let's see, tech coin. So this is our official Hope Tech coin for now. And then we'll go ahead and put a curly bracket in, and then we'll define the address as public. So, and remember, making things public makes it viewable. And then we are going to type in minter. So what we just wrote in this initial aspect of the contract is we assigned an address, which is a type of state variable used to store addresses or the public half of the key pair that I mentioned earlier. And remember from the last video, public makes this accessible outside of the contract. And so the next line of code is a mapping line. And essentially what this does is maps an address of unassigned integers to a public state variable named balances. And so we're going to type in mapping, parentheses, address. We'll use next the equal sign, and then the greater than, and then unassigned integer. We're going to make this public so it's viewable, and then we're going to name it balances. I didn't type that right, balances, and then semicolon. So the next step is to create an event. Now, what an event is, it's a listening type of function. So it's waiting for something to be sent. And then with this event function, we're able to track that transaction. So, for example, we're able to track which address sent the coin, which address received the coin, and the amount that was sent in that transaction. We'll type in event sent, then we'll use the parentheses, and then address from, address to, and the unassigned integer amount, and then semicolon. Oops. Not used to this keyboard. So now the documentation says what we need next is a constructor function. So the documentation states that a constructor function is executed during the creation of the contract. We are assigning a special state variable mentor equal to msg.sender, which allows access to the blockchain. And we'll go ahead and type that in, constructor. And it does auto-populate, so when you see it pop up, you can just hit enter, and then curly brackets, and then what we want to do is use the mentor variable equal to message.sender. Oops. It picked up sender. Perfect. And then semicolon. So now what we want to do is to make it so that coins can be sent to an address and the amount sent is added to the balance of the receiver of those new coins. And so we're going to use a mint function. And so what we'll do is we'll go ahead and type in, and then we'll type in function mint. I don't know how I did that. Why it has a little underline, but oh well. Function mint, and then address. We need the receiver address, and then we need to know what the amount is that is being sent to the receiving address. And we need this to be public. In order to do this, we need to require msg.sender to be exactly equal to mentor. And so what this line does, according to the documentation, is that it ensures only the creator can call the mint function. And then what is looked at next are the balances of the receiver. And this would add the amount being sent to the receiver's balance. So now we're able to send coins to a specific address, and that amount is added to the receiver's address. But the question is, so what if the sender doesn't have enough coins? So we need to build in an error, right? So if you go to send 5 tech coins and you only have 4, then we need the contract to not go through. And so let's go ahead and create an error called insufficient funds. Or let's do insufficient funds. I like that. And so then we're going to say unit requested, and then unit. I keep typing unit. So we're going to say unit requested and unit available. Unit and unit available. So this error function is going to look at the amount requested and compare that to the amount available. So next we want to know what to do with this, right? So we're going to look at these two amounts, and what we want to say is if the sender has less than the amount requested, then we're going to revert to insufficient funds and throw an error message. So next what we want to do is create a function that looks at whether or not the right amount of funds were sent, and if not, it should throw this error message. So let's create this function. It is function send. So when the sender is sending, address receiver uint amount. So when the sender is sending an amount to a specific address, let's make this public so it's viewable. If that amount is greater than the balances, so if that amount that's being sent to the receiver is greater than the balances of the sender, so the one who initiated, then what we want to say, let's go ahead and put in a couple spaces there. Then what we want to say is revert insufficient funds, and requested amount, comma, available, colon, balances, sender, cool, msg dot sender. And that completes the function. And so what we've said here, the contract essentially is not executed if the sender sends an amount greater than the amount that they have available in their own balance. And so if they do have enough, we need to track that transaction. And so we need to subtract that amount from the sender and add that to the receiver. And so the next thing we're going to type in is balances, msg.sender, and then minus the amount, balances, receiver, it's going to receive that amount, and then emit sent msg dot sender. Yeah, looks good. Receiver, and then amount. And I think we've completed that transaction. So yeah, so it looks like we're done here with our coin example. And it looks like we have an error here. Oops. It's because I did the wrong type of bracket. That's why. I forgot a semicolon. That's good. What else did I do wrong here? Okay, I think what I missed here is that curly bracket. And then I accidentally used the wrong bracket there. So that would mean that this is wrong. All right, and then it looks like I made a mistake there, and then I think this is the last mistake here, hopefully. All right, what did I do wrong here? and I typed in unit. Done that a number of times. And let's see. And I typed in receiver wrong. And then I think I forgot a comma. There we go. So now we just had an excellent example in debugging. We can see how important it is here to watch what you're typing. The nice thing, as you saw in the tool, is we could look at the red zones and highlight where the errors are. And I think I fixed it now. There's no more red errors. So let's go ahead and click compile coin example. See what this looks like. Yes, we got a green check mark here. So things are starting to look good. And then let's go ahead and, deploy this. All right, so TechCoin has been deployed. Let's go ahead and let's change the view here so you all can see this. So it's a little bit more difficult to see, so I'll do my best to describe what's going on here. So as a reminder, we compiled the contract, we've deployed it now, and so we have the ability to mint tech coins and send those tech coins. And so if you should see something like this: mint, send, balances, and minter. So now what we're going to do is test our functions here. We are going to mint 5 coins. But we need to mint that to a specific address. So let's go ahead and expand this and mint it to the first address that we have in this account. So we're going to transact that. Okay, so it looks good. And I don't see balance change. So that's kind of interesting. So now, let's actually copy that address and see if there is there is a balance change. Okay, great. So, you know what? I think what's going on here is it's only stored within the contract here, but not on these accounts. All right, so that worked. So you saw that I had entered the address and I added the amount of 5 tech coins to the minting address. And when I minted it, I checked the balances and there are 5. So this allows me to create as many coins as I want at this address. Now we want to send these coins to a different address. So let's go ahead and let's send 3 of our coins to the second address on our list. So I'm going to send. All right, we got a green check mark. So that worked. And then let's go ahead and check our balance at that previous address again. Great, it worked. So we're seeing a balance of 2 right here. So let me go ahead and zoom in a little bit so you can see what's going on. All right, so we minted 5 tech coins, and then we sent 3 tech coins to the second address that I have up here that's available to me in this test environment. And then we checked the balance of the original address and found it to be 2. So 5 minus 3 is 2. So let's go ahead and click on the minter. And this shows which address is the minter, so the sender essentially, which was that original address, and this value here matches that. All right, so we have tested our contract and we went through and learned a lot here, learned how to use the debugging functions and look at our errors and fix those errors, as well as running through how this minting process works on a simple basic subcurrency contract. That's it for today. In the next 2 episodes, we are going to cover some of the foundational concepts like setting up your programming environment and then more complex examples. Thank you guys, and we'll see you next time.
If you enjoyed today's video, you can like and subscribe down below. You can also sign up for our newsletter at hopenlc.org.